So this video is on the chapter 8, D-Day number 1. So on this first problem, calculate the area and the arc length of the sector shown at the right. Leave your answer in terms of pi. So for this, the very first thing I want is to just make sure everyone understands how to find the area of a circle and the circumference. So area of a circle is equal to pi times radius squared. And your radius is from your center out. So our radius is going to be that 9. Circumference, I'm going to write two equations for circumference. Pi times diameter is one of them. Or a diameter is really 2 radii, so it's also 2 pi r. So what I'm going to do is I'm going to find the area of the whole circle and the circumference of the whole circle, and then find the part that I have. So the area of a circle is going to be 81 pi. Now, I don't have the whole circle. I have a portion. I have 100 degrees out of 360 degrees. I'm going to multiply that together, but when I multiply it, I'm not going to put my pi in so I don't get a decimal. So when I do that, 100 over 360 times 81, I end up with 45 over 2, so 45 pi halves, or 22.5 pi. So those are going to go for area of the sector, either one of those. Now for my circumference, my radius is 3. My radius is 9. So my diameter would be 18, because if I double 9, I get 18. So my circumference is going to be 18 pi times, again, the portion of it I have, which is 100 out of 360. And so when I put that into my calculator, I end up with 5, so 5 pi. So that's going to be my arc length. On number 2, I am going to be looking at these two similar shapes here. What I know is happening from here to here, you can either think of it as I'm dividing by 3, or I am multiplying by 1/3. Okay. So what is a linear scale factor? I'm going to say it's 1/3. I'm going to say that I'm going a third. This one here is a third of the original one. Now, what is the area of the smaller one? So if I am timesing the sides by 1/3 or dividing by 3, the area is going to be divided by 3 squared, or 9, or times by 1/3 squared. So I'm going to take 306, which is the area. I am going to times it by 1/9 or divide it by 9. Because whatever my scale factor is for the sides, my area is that scale factor squared. So it is going to be 34 units squared. Number 3, we want to find the area of a regular hexagon with a side of 14. So let me get a hexagon here. So I am going to come here to add media, go to the Google search, and I'll put in a hexagon. And I'll insert this. That way I don't have to draw it. Okay, so we want to find the area of this regular hexagon. So I know for this hexagon that it is regular and that its side is 14 centimeters. So going across, let's say here, is 14 centimeters. Now, when I draw my triangles here from my center to each of the vertices, I am going to have 6 equilateral triangles. Now, these are equilateral triangles because I know that when I take 360 degrees and divide it into 6 equal angles, which is going to be what's happening as I go around here, I end up getting 60 degrees. So each of those central angles there is 60 degrees. So this is going to be 60 degrees. Now, for all polygons, you end up, when you have regular polygons, getting isosceles triangles when you draw them from the center to the vertices. Now, in this case, for a hexagon only, since I've already used 60, that means I'll have 120 left over to split between the other two angles, which means they are also 60. So I end up with an equilateral triangle when I have a regular hexagon, not with any other shape. So I do end up with equilateral in this case. Okay, every other case is going to be an isosceles. So I am going to get a triangle here. So I've got a triangle. And I know that going across this bottom, this was 14 all the way across. I also know that this is 14 because it is an equilateral triangle, and the third side is too. But what I am going to do is I'm going to split this in half, making a 30, 60, 90. So again, it was 60 across the top here. So when I split it in half, I'm going to get a 30, 60, 90. So when I'm trying to find the area of this triangle, and I know that from all the way across this is 14. So that means all the way just to here is going to be 7. And since this is a 30, 60, 90, that means that when I'm going and for my height here across from my 60, it is going to be a 7 root 3. So if I want to find the area of the whole entire triangle, okay, the whole entire triangle. So let me just make sure everyone understands what I'm talking about. The whole triangle. I am going to end up going 1/2 times my base, which is 14 all the way across, times my height, which is 7 root 3. And I have 6 of these triangles. Now, when I do that math, I am going to get a half of 14, 7. 7 times 7 is 49. 49 times 6, I get a 294 root 3. And that is my area. And this is going to be, put my units in here, centimeters squared, square centimeters. So that's the area. So on number 4, they want us to plot these points. So let me plot these points. -4, 6. So -4, 6 is right there. 1, 10. So 1, 10 is right here. 4, 5. So 4, 5. And -1 comma -1 comma 2. So -1 comma 2. And let me connect these with a line. Okay, so connect those. And let me just label these. So this one was L, this one was A, this one was M, this one was P. So we have this quadrilateral and they want to know what shape it is. So in order to find the shape, I need to talk about a couple things. I want to find the sides and I want to find the slopes here. So I am going to be looking at slope triangles here. So for this one, we went up 1, 2, 3, 4 over 1, 2, 3, 4, 5. So that slope is 4 over 5. Now, if I'm doing Pythagorean to end up finding the length, the math I'm going to be doing 4 squared plus 5 squared. So 16 plus 25. And I end up getting a 41. So this is going to be the square root of 41. Now, when I'm looking over at this one, going down 1, 2, 3, 4 over 1, 2, 3. So this is going to be -4 over 3 is the slope. And I will have 4 squared plus 3 squared. That is going to be a 3, 4, 5 right triangle. And so I am going to get a 25 here. So again, a 3, 4, 5, this is 5. And when I'm looking at PM, I'm going to have 3 and 1, 2, 3, 4, 5. So this is going to be 3 over 5. And if I'm doing Pythagorean, let's say 3 squared plus 5 squared. So 9 plus 25, I end up with 34. So that means that this length here is going to be the square root of 34. So the next one, let's see. I am going to find this. And so 1, 2, 3, 1, 2, 3, 4, 5. So this is going to be a negative, get the negative in front, a negative 5/3. So when I do Pythagorean, this I'm going to end up getting the square root of a 34 also. So I have two sides that are the same next to each other. These ones are not, so this is not like a kite. I have a right angle in this because my -5/3 and my 3/5 are negative reciprocals. So this is perpendicular. These ones are not perpendicular. These ones are not. These ones are not. So I am going to have a quadrilateral with one right angle. Okay, so we have a right quadrilateral, but again, it's only this angle that gives you the right angle. The rest of them are not. And it happens to have two equal sides. So find the equations of the diagonals LM and AP. So let me come to my picture. So LM. So I'm going to draw that in black. I'll kind of do it as kind of a gray here. Actually, let me do a line segment here. So LM, I'm going from here to here. And we want the line segment. So first off, let's figure out the slope. So I'm going down 1 over 1, 2, 3, 4, 5, 6, 7, 8. So negative 1 over 8 is going to be that slope. So, oops, let me get out of drawing in lines. So the slope of this one is going to be a negative 1 over 8. Now, since it's a negative 1 over 8, what's going to happen is right here, if I'm going down 1 over 8 and halfway in between is 4, instead of going down 1 over 8, I can go down a half and over 4. So I'm going to actually have a y-intercept right here at 5.5. So that means my line is going to be y equal negative 1/8 x plus 5.5 or 5.5. Now I'm going to do the same for AP. Okay, so for AP, let's say I draw that one in blue here. And so I'm going from here to here. And the slope of this, I'm going to be going up 1, 2, 3, 4, 5, 6, 7, 8 over 2. Up 8 over 2. So that slope for that blue line is going to be positive 8 over 2 or 4. So I'm really going to go up 1, 2, 3, 4 over 1. So I actually have a y-intercept at 6. So this is going to be y equal 4x plus 6. So y equal 4x plus 6. Okay. On number 5, we have an octagon with a radius of 10, and we want to find the area. So when I draw out my triangle, okay, again, this will be isosceles. It's not going to be equilateral because when I have my, oops, let me get out of lines. When I have my triangle, I am going to be taking 360 divided by 8, and 360 divided by 8 is 45 degrees. So this here is going to be 45 degrees. Let me write it here, 40, let me just write it smaller. So that's going to be 45 degrees. So if that is 45 degrees, half of 45 degrees is going to be 22.5. So this is going to be 22.5. And we know that this is 10. So I need to find 2 pieces of information. I need to find this, and I need to find this. So let's call this X, let's call this Y. And I am going to be using trig, and I'm going to be going from this angle here. So when I'm going from this angle, so let's see, if I'm going to find my X first, let's say, I am going to take, this is going to be from my 22.5, opposite over hypotenuse, that's going to be sine. So I'm going to go sine, let me make this a little thinner. I'm going to be doing sine of 22.5 degrees is equal to x over 10. I am going to multiply by 10, and I'm going to get 10 sine 22.5 degrees equals x. And that means that orange is 10 sine 22.5, and all the way across this in green would be double that. So it's going to be 20 sine 22.5 degrees. Make that a little thinner. Okay, so now let me find my y. And so for my y, again, from this, it's going to be adjacent over hypotenuse. So then that's going to be cosine. Cosine of 22.5 degrees equals y over 10. Do the same thing, times by 10 times by 10. And I'm going to get 10 cosine of 22.5 degrees is equal to y. So my height over here is going to be 10 cosine of 22.5 degrees. So now when I'm going to find the area of one of these triangles, I am going to take 1/2 times my base, which is 20 sine of 22.5 degrees, times my height, which is 10 cosine of 22.5 degrees. Then I am going to multiply that by 8 because I have 8 of these. And I'm just going to put all that into my calculator, making sure my calculator's in degrees. 8 times 0.5 times 8 times 0.5 times 20 sine 22.5 degrees, close my parenthesis, times 10 cosine of 22.5 degrees. And I ended up with about, if I approximate, 282.84 and centimeters squared. And that's going to be my area. So on number 6, these ones are dealing with exponents. So what we want to remember, and they want us to write this as positive exponents, but what they really want us to do on this one is this is going to be the cube root. I would write it as the cube root of 125. And then we're going to take that answer and square it. That's how I would do it. They want the actual answer. So the cube root of 125 is 5. And 5 squared is 25. And that's your answer. Okay, and I need to see work on that and not just an answer. On B, -5 times 7 is going to be a -35. My a times a to the third, I add my exponents, and the a really has an exponent of a 1 here. So 1 plus 3 is 4, so I have a to the fourth. B to the -1 times b to the second. Again, I take -1 plus 2, and I get b to the 1. Or I can just write it as a -35, a to the fourth b. And that is my answer. On C, everything in here is going to be raised to the second power. So 64 is going to be raised. X to the -8th, power to power you multiply. Y cubed raised to the second, power to power you multiply. So that's going to be 64 y to the 6th I do not want negative exponents. So when you have a negative exponent, you can bring that down. And when you move it from top to bottom or bottom to top, the exponent sign becomes opposite. And that's your answer. So on these ones, they want us to find the variables that they label, and they want us to leave it in simplified radical form. So these ones I should not be using trig. I'm going to use the ideas of 30, 60, 90, or 45, 45, 90. Now, what I need to be careful of, in this first one, this is going to be a 45, 45, 90. So this side and this side, this is isosceles. They're going to be the same. Now, normally I would take the legs here, times them by a √2 to get this. So what's going to happen is I'm going to go backwards. I'm going to be taking 12 and I'm going to divide it by a √2. We don't like to leave things with a radical on bottom, so we're going to rationalize. So I'm going to multiply the bottom by √2 and the top by √2, because when I do that, a √2 over √2 is just a 1. And this is going to end up giving us a 12 √2 over 2, which cleans up to a 6 √2. So both of these are going to be a 6 √2. On B. So on B, we have a 30, 60, 90. So this is going to be our 60. Now, across from our 30 is kind of like your building block, if you want to think about it. You're kind of like your base. If I know this, I double it to get my hypotenuse, and I times it by √3 to get my y over here. So that means it's going to be half of my hypotenuse. So that means x is going to be 5. And then the one across from my 60 is going to be 5 times √3. On C. On this one is one where we have the mid segment, okay? And what that means is that, so this is the mid segment theorem. And what that means is that since this is halfway in between here and here, these are both the same length, okay? Which means that this side of this triangle, if I double it, I would get this side. So this side is twice as big as this side. Now, the same thing's happening over here. Now, these are not the same size as this, but they are also split in half. So this triangle side, if I double it, I get this whole side. So when you have a mid segment, which is joining one midpoint from one side to the other one, you end up with a situation where the smaller triangle, this one here, oops, I was going to highlight it. The smaller triangle, if I multiply all of those sides by 2, I end up getting this bigger triangle. So what that means is the base right here, okay, this one I'll be doing in, I'll do it in this pink. This base here, if I was to double that base, I am going to get this base because they're proportional. So I can double this and I'm going to get 6x plus 18 when I double it is going to equal the bottom base, which is 8x minus 22. I subtract 6x from both sides and I get 2x. I'm going to add 22, so I'm going to end up with 40. Divide by 2 and I get 20. So my answer is 20. And again, this is going to be from what we call the mid-segment theorem, where I take the midpoint of one side of a triangle, connect it to the midpoint of the other side of the triangle, When I do that, these sides are split in half. These sides are split in half. So this length is going to be half as much as the whole thing. And this length is going to be half as much as the whole thing. So this triangle is half the size of the bigger one, which means so is it with the base. Because I have side, angle, side going on. So these are going to be similar triangles. And again, the bigger one's going to be twice as big. On D. Okay, so in a situation like this, this is a quadrilateral. So if I go 4 minus 2 times 180, and what I'm doing is I'm using one of the formulas, but you can think of it as if I was to draw triangles, you see I get 2 triangles. And so I get 2 times 180, okay? 4 minus 2 is 2 times 180, which is going to be 360 degrees. So I'm going to take x plus 2x plus 3x, which is going to be 6x, plus that 90 degrees is equal to 360, and I'm going to solve. So I am going to minus 90 from both sides, and I get 270. I'm going to divide by 6, and I get x is equal to 45 degrees. So 45 degrees, and in sum of interior angles of quadrilateral is 4 minus 2 times 180, or 360 degrees. So they have to add up to 360. On E, this time I have a pentagon. 1, 2, 3, 4, 5, just double checking. So in that case, I am going to be taking 5 minus 2 times 180. So it's going to be 3 times 180. Again, I would have one triangle here, another one here. I have 3 triangles, each of them being 180. So 3 times 180, I end up with 540 degrees. Now, something else I need to pay attention to is that's 63 degrees. So if I do 180 minus 63, I end up with 117. So this is 117 here. Okay, so now when I write my equation, I am going to take x plus x plus x plus 3, which is going to be 3x plus 3. I'm going to add my 117, which is here, and I'm going to add my 90. And together that is going to be 540 degrees. So I'm going to get 3x, and then 3 plus 117 plus 90, I end up with 210. So I get 3x is equal to 330. So x is going to be 110. So it's going to be 110 degrees. And I was going to say sum of interior angles of a pentagon we end up having 540 degrees. Again, I showed up here that it's 5 minus 2 times 180, or 540. On number 8, a regular polygon has 20 sides. What is the sum of the interior angles of the 20gon? So I can take 20 minus 2 times 180. So basically 18 times 180, and I get 3,240 degrees. What is the measure of an interior angle of this? So I'm going to take 3,240 degrees. I'm going to divide that sum by 20 because each of them are going to be the same, and I get 162 degrees. Then it's asking what is the measure of an exterior angle. So I can take 180 degrees minus 162 degrees because the interior and the exterior together add up to 180. And I end up with 18 degrees. I can also think about 360, which is the sum of all exterior angles divided by 20, which also gets me 18 degrees. Number 9, a regular polygon has an interior angle measuring 160. How many sides does the polygon have? So what I'm going to do is I'm going to kind of think about this differently. So if I have my interior angle, okay, so let's say that this is my polygon, okay, and I know that my interior angle here is 160 degrees. That means that if I was to have an exterior angle, it's going to be 20 degrees because again, they have to add to 180. So I'm going to take 360 divided by 360 degrees divided by 20 degrees to see how many that I'm going to have. And 360 degrees divided by 20 degrees is 18. There's 18 sides. So this is going to be an 18 gone. What is the sum of the interior angles of a polygon? Well, if I have 160 degrees for one angle and interior angle, I have 18 of them, I'm going to multiply and I end up with 2,880 degrees. What is the measure of an exterior angle? I found that it is 20 degrees. That's what I found in problem A first. On number 10, the perimeter of a regular polygon is 84 feet. So I know it's 84 adding up all the way around. And exterior angle of it is 30 degrees. So if I take 360 degrees, divide it by 30 degrees, 360 degrees divided by 30 degrees, I get 12-sided polygon. So what that means is I am going to have 84 split into 12 equal pieces. So 84 divided by 12, I end up with 7. Each side is going to be 7 feet. On 11, what's the area of the shaded region? So if this is 8 going all the way across, what that means is in the circle, this is also 8 going across, which is a diameter. So if it's a diameter, it's also going to be 8 going this way. So this is going to be 8. This is going to be 8. So what that means is this whole entire side here is going to be 16. So I know for my rectangle, I would have 16 by 8, and 16 times 8 is 128, but I don't have all of that. And so for my circle, and I actually have 2 circles. So for my circle, I know for that area, my diameter is 8, so my radius is 4. So that means that this is going to be 16 pi. So I'm going to have 16 pi here and 16 pi here. So I'm going to be taking 128, which is the whole entire rectangle, and I'm going to be subtracting 16 pi, which is 32 pi. And that is my exact answer. 128 minus 32 pi, if I put it in my calculator, as a decimal approximation would be 27 point, let's say 47 inches squared. But 128 minus 32 pi is the exact answer.